In this video, we're going to look at solubility when we have common ions. So what happens to the solubility if you add a compound in which one of the ions is common, the same, as that of the insoluble? So when I have silver chloride and just put it into plain water, you see here I have some amount of precipitate. But if I add the same amount of silver chloride to a solution of sodium chloride, in which the chloride is the common ion, okay, so it's not going to be the same compound, but one of the two ions will be the same. In this case, it's chloride. Then you see that I have a much larger amount of precipitate that forms at the bottom. So by adding a common ion, I always reduce the solubility of my insoluble salt. Okay. So an example of this is that it wants to know what is the molar solubility of barium fluoride in a 0.15 molar sodium fluoride, and I give you the KSP. So I want to know what the solubility of BaF2 is equal to in molarity, because that comes from the molar, and I have a concentration of NaF of 0.15 molar. I have a KSP of 1.0 times 10 to the minus sixth. And it also wants to know what the solubility of the barium fluoride is in water without a common ion. Okay, so as usual, the first step is to write out the equations. So BaF2 goes to form barium 2 plus 2 fluorides. Okay, I need to, because of the fact that I have a KSP, it's asking for solubility, I have to do the ice table. So I, C, and E. Barium fluoride, being a solid, is not going to be included. Now, what's different about this problem than the previous problems is the fact that while I don't have a source of barium, it has a 0 molar concentration. I do have a source of fluoride. So when I look at this, when I look at this, okay, I have fluoride and fluoride. So when I look at the sodium fluoride, what's the common ion? Okay, and it is the fluoride. So I have a 0.15 molar of sodium fluoride. This is going to be X, and this is going to be 2X. Now, we did these problems in chapter 16 also with buffers, okay? And anytime I have an initial concentration of either one of my ions, then I basically can ignore the 2X there, okay? So my KSP is going to equal to my barium concentration times my fluoride concentration squared. So I have 1.0 times 10 to the minus sixth is equal to X times the 0.15 squared. So I simplify the right-hand side. It's going to be 0.0225x. So 1.0 times 10 to the minus 6 divided by 0.0225 is equal to X. X then is equal to 4.45 or 4.4 times 10 to the minus fifth molar. Okay, so that's the answer to the first part. Okay, so now we'll do the second part. How does this compare of pure and pure water? Okay, and so I'm going to do the same thing, except for the fact that now this is going to go to 0, and I now have to include my 2x. Okay, so I'm still going to have the same KSP expression. So it's going to be 1.0 times 10 to the minus 6 is equal to x, but now it's going to be times 2x squared. So 1.0 times 10 to the minus 6, so x times 4x squared gives me 4x to the cube. So divide both sides by the 4. And I get 2.5 times 10 to the minus 7th. And I take the cube root of both sides, so I'm going to reverse this. It's going to be the cube root of 2.5 times 10 to the minus 7th. And so x is 6.3 times 10 to the minus 3 molar. Okay. If I compare these two, this one's larger. So in pure water, it's going to be larger than if it is in a common ion, which is what we saw in the previous slide. By adding a common ion, I reduce the solubility. And that's what I see here is that in water, it's higher than if I have the presence of fluoride. So let's do one more example of that. Okay. Again, it wants to know the solubility of AgCl. It doesn't specify the units, so I'm just gonna, so if I don't specify, you can leave it in molarity. Okay. I have a concentration of HCl that is 2.0 times 10 to the minus 2 molar, and I have a KSP of 1.8 times 10 to the minus 10th. So my equation is going to be AgCl goes to form Ag plus Cl minus. Do my ice table because again I have the KSP and not the solubility. I have 0, well, okay, before I start filling in the I, what ion is common? Is it which ion is common? Silver or chloride? So I look at this, here's my solubility, but which one is in here? Okay, and it is the chloride. So I have to look at the two different compounds. So when I go to fill this out, this is going to be 0. This is going to be the 2.0 times 10 to the minus 2. It's going to be x and x, but because I have an initial concentration here, I can ignore that. Okay. My KSP expression is going to be the silver plus times the chloride minus. So I have 1.8 times 10 to the minus 10th is equal to x times 2.0 times 10 to the minus 2. So I divide both sides by that 2.0 times 10 to the minus 2. To give me x, and so x ends up being 9.0 times 10 to the minus 3 molar. Okay, and that is going to be the end of my video.